Good evening, everybody. We are working today on page 85. This is section 2.1, Patterns and Inductive Reasoning. Now remember what inductive reasoning is. Inductive reasoning is the ability to observe a pattern and make what are called conjectures based upon that pattern. We make the assumption that the pattern is going to continue and act therefore. Now, whenever you hear an inductive reasoning question, I want you to immediately think of a stoplight. Red light, green light, yellow light, red light. That pattern repeats. Even though I've never been in Boston before, if I were to go and drive in Boston, I would make the assumption that their stoplights are going to work just as much as ours. That is the recognition of a pattern and then a progression based upon that pattern. Okay, so we're looking at, page 85, you had 6 through 10 even, 24 through 31 even, and 33 through 37. So we're going to start off with 6 through 10 even. Now 6 through 10 even, they're all just pattern recognition and using that pattern to show the next two terms. So if I go, let's say number 6, we have 5, 10, 20, 40. Now here, this one's pretty simple. What you're going to do is each one of these is times 2. 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. So then we go 40 times 2, we get 80. 80 times 2, we get 160. So that'd be number 6 right there. And that's it. Now, 12 is a little sticky. So if we go 12, O, T, T, F, F, S, S, E. I'm going to be honest with you, this one I had to look up. I have absolutely no clue how you're supposed to get this one by yourself, but it is the first letters of counting numbers. So if we go 1, 2, 3, 4, 5, 6, 7, 8. So then our next two are going to be N and T for 9 and 10. Hope that makes sense. So that's what you're going to do. You're going to go through and you're going to identify and then add. So you identify the pattern first, and then you make assumptions going forward based upon the belief that that pattern is going to continue. Again, that is called pattern recognition, and then the making the observation that it will continue, the conjecture that it will continue as follows, is the application of inductive reasoning. So next problem set, we're 24 through 31 even. Now, some of these, it really helps if you were in class, because what we did was we went ahead and we actually figured out what the pattern was, how the pattern works, and that way we were able to figure it out without adding them up. So let's look at number 26. Sum of the first, lost my eye right there, 100 positive even numbers. Okay, so in case you're wondering what that means, that's 2 plus 4 plus 6 plus 8. And you go all the way. Now you have to understand, though, that this is the first, second, third, and fourth even number. So how do we figure out what the 100th one is? Well, at the beginning of class, when we were going through this, we realized that the answer, the sum of those numbers, sum of consecutive evens looks like this: n times n plus 1. So notice that if we took the second or the fourth one here, so here we can add them up. We can 2 plus 4 is 6, 6 plus 6 is 12, 12 plus 8 is 20. Okay, so we know that the first four should go to 20. And, okay, hold on just a second. Should go to 20. And then what?
Was alive when he went into the sea.
Stainless steel blade, acid etched and hand polished. The fittings, guard, and pommel, 24-karat gold plated. As late as the 1800s, a sword like this would have been used to defend against an enemy trying to board a ship. Only the blade would have been sharp enough to take a man's limb off. I always liked pirate movies, didn't you?
Not really.
Of course, today, it wouldn't stand much of a chance against a 9mm H&K MP5 Parabellum, would it?
I guess you like gun movies, too.
I like all weapons, sir.
I can really appreciate that, Ensign. All the officers' ceremonial swords accounted for?
Yes, sir. Sector 32 officers found 32 swords, including my beauty.
We're going to need to take a look at all of them.
Yes, sir.
So where do you think McDonald could have acquired the sword?
The only place where they sold them. The base exchange.
Roosevelt Roads Naval Station?
Yes, sir. This place was last in second.
Okay, so there's a little bit of a jump there, so sorry about that. Going back, there was a connection issue. So the sum of consecutive numbers is going to be n times n plus 1. Now, that is the term. So here, if we add up these four right here, we get 20. So if this is correct, we should be able to go sum of the first four. Sum of the fourth is 20. So let's check it out down here. We go 4 times 4 plus 1. That gives us 4 times 5 equals 20. So that works. But we're looking for the 100th consecutive number, right? 100th positive even numbers. So we're going to go 100 times 100 plus 1. And that gives us 100 times 101 equals, we just write 101, tack on those two zeros. So if we add up the first 100 positive even numbers, you would get 10,100. Hope that makes sense. So that leads us to our final set of problems, and that was 33 through 37. Now 33 through 37, we're looking for counter examples. Now remember we talked about truth values. Okay, so a truth value of any if-then statement, so any conditional, is true if no counterexamples and false if one counterexample. Now, it's important to understand that this, when we're talking about logical truths and faults, that is different than factual truth and fault. Logical truth and fault breaks down in the way that if there is even one exception, then the whole statement is considered false. So if I said, if it is Colorado, then it snows in the winter. Okay? If we went back and let's say 200 years ago, it didn't snow one winter in Colorado, then that would be a false statement. Even though for the past 199 years it has snowed, the fact that we can have one counterexample makes the entire statement false. So let's just look at one of these. Let's look at we're doing 33 through 37, so let's look at 33. Look at 33, and it says angle 1 and angle 2 are supplementary. Now we should all know that supplementary means that they add up to 180 degrees. And so we say that 1 and 2 are supplementary, so one of them is acute. And this is one of those examples that I told you about. If we have a straight line here, so we know that any two supplementary angles equal 100 degrees. And we start here or there or there or there or there or there. We can draw an infinite number of angles. And the vast, vast majority of 99.999% that statement is going to be true. But there's one example where it's not. And that one example is where you have two 90-degree angles. Now remember, right angles are neither acute nor obtuse. That's my cat. Say hi. Say hi to the cat, everybody. Hey, Cleo. See, I feel safe doing that, knowing that no one in their right mind is actually going to watch this. Heard me say hi to Cleo? Comment hi, Cleo, in the comments, which we're 12 minutes in, so I know if you're actually watching this, you're all going to be asleep by now anyway. So, remember, right angles are neither acute nor obtuse. They are their own type of angle. So on this one set of angles, 90-90, we have absolutely, that's wrong. So because there's only one example where that's false, the statement itself is false. 50, if you're looking at number 50 and having trouble with it, 50 forms a pattern. Best way to do that is to go ahead and just plot those points. I think there are about 15 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Exactly 15 of them. 14 of those patterns make a specific pattern. 14 of those points make a specific pattern. One of them is outside of that pattern. Figure out which one that is and put that down and explain what the pattern is and which one's out. If you have any questions, comment below. Go ahead and email me. Thank you very much for watching.